numbers. So write chapter 1, real numbers. Chapter 1, real numbers. Real number means the set of all rational number and irrational number. These together called real numbers. Rational means, last class we wrote the basic. What is rational number? That is a decimal form. Okay. What's the definition of rational number? P by Q, where Q is P and Q are and coprime. Do you remember that word coprime? What do you mean by coprime? Common factor is only one. Very good. Common factor is. That means it will be in the simplest form, right? When you write the P by Q, it will be in the simplest form. That is called a rational number. So all rational numbers will be there in real number and irrational also will be there. Irrational means the one which is not rational. For example, if we cannot find out the root of a number as an integer, it is irrational, like root 2, root 3. Okay, this two definitions you have written already in the notebook, in the basics you have written. Okay, so here we start with the real number. This is the definition of real number. Right, definition. Definition. The set of all rational and irrational numbers. The set of all rational and irrational numbers the set of all rational and irrational numbers are called real numbers. Okay, the set of all rational and irrational numbers are called what type of numbers? Real numbers. Okay, so now you try it. What are rational, what are irrational again? Next, prime number and composite number that we use in the first definition. Okay, our first definition is fundamental theorem of arithmetic. I'm coming to that one. Before that, do you know what are prime numbers? What is the smallest prime number? 2 is the smallest prime number. Okay. Prime number means the number which has only two factors. The factors are 1 and the number itself. For example, 2. Okay, so I write a number here and factors here. Number and factors. Number and factors. 1, the factors of 1 are 1 and 2. What are the factors of 3? 1 and 3. 3 into 1 is 3. What are the factors of 4? 1, 2, and 4. It is not a prime number. Prime number has only two factors, 1 and the number itself. What is the next prime number, 5 is the next prime number because the factors are 1 and 5. What is the next prime number? 7 is the next one. 1 and 7. Next, 8 is not a prime number. The factors are 1, 2, 4, and 8 because 4 2s are 8. Okay, 1, 2, 4, and 8. 9, is it a prime number? No, because 3 3s are 9. So we write 1, 3, and 9 are factors of which one? 9. So next is which one? 11. 11, 1, and 11. Then 13. What are the factors of 13? 1 and 13. Next prime number is which one? 17. 1 and 17. Like this it will go on. Okay. And the other numbers are composite. But what about 1? 1 has only one factor, 1. Is it a composite number?
Sir?
Is it a prime number? From online, can you respond? What about 1?
Sir, could you scroll up?
Chris, you were not there last class, right?
No, sir.
Last class, I explained all the basics. Okay, basics are required for class 10. Okay.
Yes, sir.
So the last class, let me see, record I will share with the absentee students. Okay, I think it is recorded last class so that you can easily complete the notes. Who all were absent last class? Steve, Crit, and Chris. Please send me a message by the evening, okay? And to get the record. And you have to write that basics. And today I just started with chapter 1, real number. And it is a continuation of last year's number system. It means the set of all rational and irrational numbers are called real number. And now I came to the new point, which one? Prime number. What is prime number? The number which has only how many factors? 2 factors. 1 and the number itself. That is called the prime number. My question was, other numbers are composite, right? 9 is composite, 4 is composite. Actually, 4 is the smallest composite number. Then what about 1? 1 class 5 or 6, you have studied this one. 1, neither prime nor composite. Because 1 has only one factor, 1 itself, right? It is neither prime nor composite, okay? If you have small brothers or sisters at home, okay, class 5 or 6, you can explain it to them. Okay, they will be very keen to listen to you when you explain, okay? You have to explain it to them. This is prime number because these are all there in class 5 or 6. Anyone of your brother or sister is there in class 5 or 6? Yes. You have to call them, tell them, I will explain what is prime number, composite number. So in addition to that one, you will say, oh, 1 is neither prime nor composite. So all of you understood what are prime number? The number which has only 2 factors, 1 and the number itself are called the prime numbers, okay? The number which has more than 2 factors are called a composite number. Just write a definition of that one and some examples. And those who want can note down these things in the refer space. Which one? That prime number, okay? And composite number examples, right? Prime numbers. So prime numbers means the number which has only 2 factors, semicolon, 1 and the number itself. 1 and the number itself is called a prime number. The number which has only 2 factors, 1 and the number itself is called, what type of number is called a prime number? Is called a prime number. Example, 2, 3, 5, 7, 11, etc. 2, 3, 5, 7, 11, etc. That is example. 2, 3, 5, 7, 11, etc. Yes, did you write this one? Those who want to note down this one, you can write that in the refer space. Number and the factors I have written. Okay, 1 and the number itself. Its clear explanation is there. Next, composite numbers. Composite numbers. composite numbers. Right, composite numbers. The number which has more than 2 factors. More than 2 factors is called a composite number. Right, the number which has more than 2 factors. The number which has more than 2 factors is called a composite number. Please write. The number which has more than 2 factors is called a composite number. Example, 4, then 6, 8, 10, etc. 4 is the smallest composite number, okay? Even 9 also there, 9, 10, etc. 9 is also a composite number, then 10, etc. This type of numbers are composite numbers. So what is the smallest composite number? 4 is the smallest composite number. What is the smallest prime number? 2. Okay, what is the only even prime number? 2. 2 is the only even prime number. Other prime numbers are all odd numbers, okay? Yes. Prime factorization you have studied in small classes. All of you know that one, okay? We will use that one in the first definition. Actually, this is a revision from small classes. So our first definition or first theorem, we say, it is fundamental theorem of, before that, about 1, we have to write a word. 1 is neither prime nor composite. Write a short note, you can write. 1 is neither prime nor composite. One is neither prime nor composite. Please write. 1 is neither prime nor composite. 1 is neither prime nor composite. Yes, those who attend online, did you complete till here?
Yes, sir.
Yes.
This definition. Okay. Next is fundamental theorem of arithmetic. Next subheading, fundamental theorem of arithmetic. Right. Fundamental theorem of arithmetic. This will come for a 2-marker question. 2-marker, normally the definition also will be coming in the examination. State fundamental theorem of arithmetic, direct question will come. And questions based on this one also will be there in the examination. Okay, so in small classes we studied, if you take a composite number, for example, 24 is a composite number. That composite number 24 we can factorize. 24 is divisible by what number? Prime factorization 2. When you divide by 2, we get 12, right? Again, we divide by 2 until we get a prime number. So we get 6. Again, by 2, we get 3, 3, 1, right? And then we can express 24 in this form. 24 is 2 cube into what? 2 cube into 3. And this is called the fundamental theorem of arithmetic, which means every composite number can be expressed as the product of what? Product of prime factors or prime numbers. Are you getting? Every composite number. Okay, every composite number can be expressed as a product of prime factors. Okay. That prime factors order we can change, like 2 cube into 3, we can write 3 into 2 cube. It is not a problem. Okay. So that is also written as the part of that one. And this factorization is unique apart from the order in which the prime factors occur. Unique in the sense 2 cube into 3 or 3 into 2 cube. That is the only way of factorizing this number. Okay. If you want to write 2 raised to 4 in this one, is it possible? No, it is not possible. So this is the only way of writing. That is what additionally it is written. This factorization is unique apart from the order in which the prime factors occur. Order we can change, 3 into 2 cube. It is not a problem. So please write this as a definition. The statement. Every composite number, right? Every composite number can be expressed as the product of prime factors every composite number can be expressed as a product of prime factors, and this factorization is unique, and this factorization is unique, and this factorization is unique apart from the order in which apart from the order in which the prime factors occur. So this is the fundamental theorem of arithmetic. Definition. Example 24. Yes, the same example we can write. 24, how can we write 24, children? 24 is equal to 2 cube into 3. It's splitting prime factors. You can write there in the upper space. So this statement may come in the examination as 2-marker question. State fundamental theorem of arithmetic. Without any change in the word, you have to write this one, the statement. Yes. So let's study it right now, the statement. Yes, what is the statement? Every composite number can be expressed as the product of prime factors. Study till there. Every composite number can be expressed as the product of prime factors. And second part. And this factorization is unique apart from the order in which the prime factors occur. Did you understand the meaning of that one? So this is unique way of expressing the factorization for this particular prime number. That's what it is written. This factorization is unique apart from the order in which the prime factors occur. Study right now. Every composite number can be expressed as the product of prime factors. And this factorization is unique apart from the order in which the prime factors occur. Yes. Study, take few seconds and study. Yes. Now, who is ready to say this one, the definition without looking there at the notebook? Yes, please.
Any constant number can be expressed as a product of prime factors, and this factorization is unique apart from the order in which the prime factorization is.
Yes, prime factors are correct. Very good. Very good. Next, who is ready to say? Can you try?
Every complex number can be expressed as a product of prime factors. The factorization is unique apart from the order in which the factors occur.
The prime factors occur, and this factorization is unique apart from the order in which the prime factors occur. Okay, you should not change this. Okay, the statement structure, because it is statement which is given in NCERT. So everybody should stick on to this one, okay, and study it perfectly. Yes, Rafika, can you say?
And the product of prime factors, and the factorization is unique apart from the order in which the prime factors occur.
Very good, very good. Ravelika, can you say? Product of. Okay, very good. Okay. So all of you studied, right? Yes. From online, who is ready to say? Sarah, can you try?
Every composite number can be expressed as the product of prime factors, and this factorization is unique apart from the order in which the prime factors occur.
Okay, correct. Okay. So all of you studied almost. And I hope you studied around 75% or more. The remaining percentage you will, your self-practice is taking place at home, right? All of you decided to do the daily practice, right? Not like last year. Everyone should practice it on the same day itself. I gave you all the instructions. And every day, minimum 45 minutes you have to spend for self-practice. Okay? And make sure that you are studying it perfectly. Sums you will write and practice. Okay? So statements you have to read and practice thoroughly. Okay? So the notebook, it's not like this. Draw the left margin using scale and pencil. Last class I gave all the instruction. Okay, watch the record and follow it clearly. Okay, left margin using scale and pencil. Heading line neatly you have to write the notebook. Okay, yes. Now we are going to do some questions based on this prime factorization. And a factor tree also I have seen in some question paper. In small classes, you have studied a factor tree. The same factorization we can represent in the form of factor tree. The same example I'm going to write in the form of factor tree. Factor tree 24, the number 24, the number 24. Yes, this is the method of writing factor tree. 24 is 2 into, we write the prime number here and the remaining composite part here. 2 into what number is 24? 2 into 12. Then from composite number, we have to draw more branches like this, more branches or more roots like this, okay? So 12 is 12, how can we write? 2 into 6. Again, 6 we can break. Prime numbers we cannot go further, okay? But 6 we can break. How to break 6, children? Yes, 2 times 3, 2 times 3. So it ends here, and we'll take this, the final primes we take, that is 2 cube into 3, that is a factor tree. 2 cube into 3 is the factor tree. Is that clear? 2 cube into 3, yes, please note down. Two cube into 3. Did you complete this one? So fast?
Every week.
Okay. So let me. Yes, finished here. Now write this one. From exercise 1.1 as per the new textbook. All textbook exercise 1.2, but all of you will be getting the new textbook hereafter. In that one, exercise 1.1, we do the questions of exercise 1.1. Right. Express each number as the product of its prime factors. Express each number as the product of its prime factors. Its prime factors. Express each number as the product of its prime factors. First question is 140, 140, 140. Okay. So we'll do the prime factorization of 140. 140, we can divide 140 by what number, children? Yes, we can divide 140 by 2. Then 2 into what number is 14? 7. And then we put 0. 2 into 0 is 0. So we get 70. 70. Is it clear? Steve, great. Any doubt? 2 into 7 is 14. So we write 70. Again, when the number ends in even number, okay, when the number ends in even number, it is divisible by 2. If the sum of the numbers is divisible by 3, that will be divisible by 3. Okay, when you add them, if it is divisible by 3, it is divisible by 3. In small classes, you have studied the divisibility check. Okay, so same thing will follow here also. So now we write again by 2. When you divide again by 3 2s are 6, right? 3 2s are 6. Then 1 is the remainder. 5 2s are 10. 35 we get. Is it clear how to break it, Josh? 2 3s are 6. Then 7 minus 6 is 1. So 10 means 2 5s are 10. 35. When the number ends in 0 or 5, it is divisible by 5. So this is divisible by 5. So what do you get? 7. 7 is a prime number. So we can write 7 and 1. So how do you write this 140? 2 square into 5 into 7. So we write here 140. This is the solution. 140 is equal to 2 square into 5 into 7. Okay. So like this we can express it as the product of prime factors. Next question. 3825.
Sir,
Yes, please.
sir, is there a way to check the divisibility for 7 and 9?
Yes. I'll explain a divisibility checking. Okay, I will give you a detailed explanation after completing this. Okay.
Yes.
3825. I'll give you 1 minute. Can you try this one? 3825. 3825 is divisible by what number? Yes, please try. I will give you 1 minute. All of you, please. So did you finish this one? So 3825 is divisible by 5. 3825 is divisible by 5. When you divide by 5, we know 7 5s are 35, right? Then we subtract, when you subtract, we get 3, 32. 32 means 6 5s are 30. Then we get 2. 25 means, what is that? 5 5s are 25. We got 765. All of you got the first step correct? Then again, it is divisible by what number? 5. 5, when you divide, 5 ones are 5, right? 7 minus 5 is how much? 2. 26 means 5 5s are 25. Yes, then 6 minus 5, 1. 15 means 5 3s are 15. Is it clear? Again, this is divisible by what? 5. 5 5s are, 5 3s are 150.
Sir, 3.
Sorry. It is divisible by not 5. Instead, we add them. When we add them, 5 plus 1 plus 3. 5 plus 1, 6. 6 plus 3, 9. It is divisible by 3. Okay, how to check divisibility by 3? We just add the numbers. When we add them, it is if it is a multiple of 3, that will be divisible by 3. Okay, are you getting? Those who want, you can note down the divisibility rule of 3. If you know, no need to write. So when we add them, yes, it is the multiple of 3. So divisible by 3. 3 5s are 15. Then how much? 1. Again, 5 plus 1 is how much? 5 plus 1? 6. That is divisibility by 3 satisfies there. When you divide by 3, 1 3s are 3, then 21 means 7 3s are 17 we get. 17 is what type of number? Prime number. All of you got till here? Is it clear? Yes. Those who have not done, please complete it. How many of you got it correct? No. 15 is not a prime number. 15 is not a prime number. We are allowed to divide only with a prime number. 15 is not a prime number. Okay, we cannot divide by 15. So we'll write this one. 3825. 3825. Yes. What is the prime factorization, children? 5 square into then 3 square into 17. 5 square into 3 square into 17. 5 square into 3 square into 17. Yes, Chris, are you there?
Yes, sir.
Yes. Abhinami, listening, right? Any doubt?
No, sir.
It's clear. Okay, till here it is perfect. Okay. In between, you asked the divisibility rules that you studied in small classes. Okay, especially 2, all of you know. What is the divisibility rule of 2? Yes, I will just write a short note there in the reference space. Any point, if you want, you can note down. Divisibility rules. This is the divisibility for 2. Ones place number must be, ones place should be 0, 2, 4, 6, 8. Okay, then that will be divisible by 2. Even number. Now, divisibility by 3 is like the sum of numbers. Sum of digits. Sum of digits should be multiple of 2. Sum of digits should be multiple of 2. Should be the multiple of 2. Multiple of 2. Multiple of 2, 3. Sum of digits must be multiple of 3. So that one we checked in the above thing, right? 153. We checked that one. Sum of digits, it is multiple of 3. Even divisibility by 9 is also the same. Sum of digits must be multiple of 9. Divisibility by 9. But 9 we don't use that one frequently because 9 is not a prime number. Okay, 9 we will not use. But that is the same rule. In between, I think somebody asked that one, divisibility by 4 also is. But 7 I will write. 5 everybody knows. So 9, this is a checking. Sum of digits, it must be multiple of, should be multiple of 9. Should be multiple of 9. And for 5, what is the checking for 5, children? Ones place should be 0 or 5. Ones place should be 0 or 5, then it is divisible by 5. Okay. Then a different checking is for 7. 7, how to check, 7? 7 we check, take the double of ones place number, ones place digit. Ones place digits, okay, digit. We have to take the double of ones place, okay. Then find the difference. We have to find the difference. Find the difference of this double with the remaining part. With the remaining part. If it is multiple of 7, then it will be divisible by 7. So what are the sentences written? Take the double of what? Ones place digit. Then find the difference. Find the difference of this double with the remaining part. Okay, if that difference is a multiple of 7. If this is a multiple of 7. If this is multiple of 7. Then it is divisible by 7.
So remaining part as in the rest of the digits.
Rest of the digit, correct. For example, 49. 49 is a number, okay, which is divisible by 7. You can check with the same rule. 49.
So could you show an example with a bigger number?
49. 49 is an example, okay. Can you see 49? I am going to write here 49.
No, but
We
sir,
take,
49 is like I already know, right, that it's 7 into 7.
okay,
Could you give like a
simply I
3-digit
will
number?
explain. Just a second, check. We take double of 9. What is double of 9? Then take the difference of that with the 4, the remaining. What is 18 minus 4? 14. So this is divisible by 7. That's a check. Okay, this is
Okay, sir.
applicable for all other numbers. Okay, we take the
Yes, sir.
double of ones place, then that one minus the remaining part. Okay, difference. Difference means whatever is bigger, that one, that difference. If it is divisible, if it is a multiple of 7, then it is. What is the divisibility by 11? We take the sum of numbers in the even places, and sum of numbers in the odd places, and take the difference of this. If that difference, if it is 0 or 11, it will be divisible by 11. This is all we studied in which class? Class 5. Take the difference of, the best thing is if small brothers or sisters at home take their textbook, okay, read it and explain it to them, okay, you will study faster.
So could you
Okay,
say
no
for
problem.
11 again?
11, we take the 11, this is the rule, I will write here, okay. 11, this is the rule. For example, 121. 121 is divisible by 11, right? We take the sum of numbers in the even places. These are the even places, okay. And the sum of numbers in the odd place here, actually these are the odd places. First place, second place, third place, like that from left to right we count. Okay. So we take this one, 1 plus 1. What is 1 plus 1? 2. Then even place also it is 2. Then take the difference of this, 2 minus 2. What is 2 minus 2? Like this, if it is 0 or multiple of 11, then it will be divisible by 11. Got it? If it is 0 or multiple of 11, then it will be divisible by 11. That means
Yes,
take
sir.
the sum of numbers in the odd places, sum of numbers in the even places, take the difference if it is. You want to write that one? Divisibility by 11. Okay, if any student wants to write, this is a rule. Take the sum of digits in the, even places, take the sum of digits in the even places, then sum of digits in the odd places and find the difference. Find the difference. If that difference is 0 or 11, then it is divisible by 11. Okay, so have you done this one? Done. Okay. Example 121. Like this, we take the sum 1 plus 1. Odd places sum we find out, even places sum, then find the difference of these two. If that difference, if it is 0 or multiples of 11, 0 or 11, I mean 0 or 11, then it is divisible by 11. Okay, 0 or 11, then it is divisible by 11. Done. No. Rule for 4, it is divisible by which one? The last two digits, it must be multiple of 4. Last two. Okay, like 4, 8, 24. Okay, multiples of 4, last two digits. Divisibility by 17, rare cases it will come. 17 is similar to that divisibility checking of 7. What is the divisibility check of 7? Do you remember? Take the double of one's place. Instead of that one, take 5 times of one's place. 5 times. Okay, 5 times. Then subtract it with the remaining. If it is divisible by 17, okay, it is multiple of 17. It is.
You have to add those first and then.
Yes. Okay, so in one question, I think divisibility by 17 is there in a quiz. There is. So write the next one. 7429. 7429. Next question is 7,429. This number, this particular number, you have to by heart this number, okay? Because this is not divisible by 2. Is it divisible by 3? Check the sum. What is the sum? 9 plus 2, 11, 11 plus 4, 15, 15 plus 7, 22.
22, it's not divisible.
It's not divisible by 3. It is not divisible by 5. It's divisible by 7. Take the double of 7 2s are 18. Then 742 minus 18. 742 minus 18, we get how much? 724. 724, it is not divisible by 7. 724 is not divisible by 7. Okay, it is not divisible by 7. What about, is it divisible by 11? Next, 11.
No, sir.
Sum of numbers in the odd places. 9 plus 4, 13. 7 plus 2, 9. 13 minus 9. No, it is 4. Okay, it is not. Then I check 17. 13 also it is not. 13 we check like this. Take the 4 times of odd place and take the difference with the other part. Okay, 4 times. Like the easy to remember. 7 2 times of odd place. 13 4 times. 17 5 times. Okay, 17 it is how much? 5 times.
So 13, 4, 5. So 13, how many times of one's place?
4 times. 4 times.
Okay.
4 times of one's place. Okay. Now I check 17. 17, what to do? Take the 5 times of 9. What is 5 times of 9, children? 45. Then 742 minus 45. What is the difference? 12. 12 means 7. Then 13, right? 3. 13. 13 means what will be that one? 9 and 6. 697. 697 is divisible by 17. That also we check again the same way. 7 5s are 35. 69 minus 35 is 34. It is fine. It's 97 is divisible by 17. So this number is divisible by what? 17. Did you understand how I checked that? First of all, I times this one by 5. The odd place 9 times 5 is 45. Then I took the difference. 742 minus 45 is 697. Okay, then again we cannot check simply. So again I took 5 times of 7, the odd place. What is that? 35. Then I took the difference. 69 minus 35 got 34. Yes, 34 is 17 times 2. So this part, 7429 is divisible by which one? 17. So we start with 17. 729. So better you have to remember this number during the exam time. It's a question from the NCERT. The same number may come there in the examination. Okay. So we start with 7429 divisible by 17. Abhirami, is it clear how to check the divisibility by 17?
Yes, sir.
Okay. So can you divide by 17? It is very easy to divide by 17. 17 times 4. What is 17 times 4, children? 17 times 4 is how much? 68. So we will note down 68. Okay. Then 74 minus 68. Subtract and tell me. 6, right? So 62. 17 into what number is very close to 62? Yes, 17 into 3. So we write 3 here. 17 into 3. What is 17 into 3? 50.
51.
Then subtract. 62 minus 51. How much we get? 62 minus 51. 11. 119. 119 is 17 into what number? 7. 17 into 7 is 119. All of you understood the first line? Great. Is it clear? 437. Yes. Now 437, it is divisible by what number? Can you find out? 437, it is divisible by what number? 437.
Sir, is there a method to find out if a number is prime or not?
That one factorization only. There is no other technique. Okay. But divisibility we can. Divisibility, different rules, it's there. Even is it divisible by this also? You better you remember. Okay. Here 17 it is not. 17 is not getting. 23 will get. 23 is correct. Even 19 also we get. 19 checking. 23 we can check. 23 I just explained. Multiple by 7, right? And then take the difference. 23 is fine. Even 19 also works. 19 is a different method. 19 checking, I just checked there in the reference space. I multiplied 7 into 2. Take the double of the odd place. Okay, what is that one? 7 into 2 is how much? 14. And add it to the remaining part. Add it to the remaining part. That is 57 I got. Okay. If that is a multiple of 19, it is divisible by 19. But multiple of 23 checking is a little more easy here. Take which one? Okay, 19 we do easily. 19. Yes, when you divide by 19, what do you get? Can you divide this 437 by 19? 437 by 19. 437 by 19. 19 times 1 is 19. 19 times 2 is how much? 19 times 2. So we take that one, 38. Then take the difference, 557. 19 into what number is 57? 3, 23. 23 is a prime number, so we stop here, 23. Is it clear? So these are the 3 primes in this one. Since the primes are too big, so better you have to by heart this particular number. Okay, the same number may come In some question papers, I have seen it. So please note down this one. 7429 is equal to 7429. How do you write, children? 17 into 19 into 23. Okay. Yes. So this way we can check the prime factorization. Yes. Next, we start a very, very important topic. We can find out LCM and HCF by prime factorization. In small classes, we have studied it. So write the subheading. LCM and HCF using prime factorization. LCM and HCF using prime factorization, right? LCM and HCF using prime factorization. Please write the subheading. LCM and HCF using prime factorization. LCM and HCF using prime factorization. Please write. Working rule. Working rule. Step number one. Express the given numbers as a product of prime factors, right? Express the given numbers as a product of prime factors. Express the given numbers as a product of prime factors. Right. Second point number 2. Express the given numbers as a product of prime factors. Point number 2. For HCF, multiply the lowest powers of common primes. Multiply the lowest powers of common primes. Very, very important word, common primes. For HCF, multiply the lowest powers of common primes. Then third point, for LCM, multiply the highest powers of every prime. Okay, so these are the working rule steps. Step number 1, express the given numbers as a product of prime factors. For HCF, multiply the lowest powers of common primes. I will explain it with example, then you will get a clear idea. For LCM, multiply the highest powers of every prime. Okay, not only the common prime, every prime. Then there is a special note. For any two integers a and b, for any two integers a and b, LCM of AB into HCF of AB is equal to A into B. Please note down. For any two numbers A and B, LCM of AB into HCF of AB is equal to, what is that? A into B. Please note down. For any two integers A and B, LCM of AB into HCF of AB is equal to A into B. Is equal to A into B. Yes, now I'm going to explain the questions based on finding LCM and HCF. Once again, all of you check the working rules. Step number 1, we have to express the given numbers as a product of prime factors that you know. Second rule is for HCF, what you have to do, take only the common primes. From the common primes, we take the lowest powers, okay, and multiply. For LCM, multiply each and every prime with the highest power. And what's the relation connecting LCM and HCF of two numbers? LCM into HCF is equal to product of the numbers. That is what it is written. LCM of AB into HCF of AB is equal to A into B. Yes, now the examples when I explain, you will understand it clearly. Based on this topic, sure questions will be there in the examination. Finding LCM and HCF, verification, all these are very important, right? Find the LCM and HCF. Question. Find the LCM and the HCF of the following pairs of integers. The following pairs of integers. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the numbers. Verify that LCM into HCF is equal to product of the numbers. First question, 26 and 91. 26 and 91. First question is 26 and 91. Okay, so when I explain this example, you will understand the working rule clearly. First of all, we have to factorize 26. Prime factorization of 26 is 26 is equal to, solution we start like this. So here I do the prime factorization. Is 26 is divisible by what number, children? By 2. And what do you get? 1 2s and 3 2s, 13 and 13 and 1. So that ends here, 2 into 13. Is it clear? So 26 we got 2 into 13, 2 into 13. Next is 91, 91, 91.
So 91 is prime.
Hmm?
91 is prime, right?
No, 91 is not a prime number. 91 is divisible by what number, you know? 7. It is divisible by 7. It is divisible by 13. Can you check 13 into 7? All of you please check 13 into 7. 13 table also you have studied in small classes, I hope. Have you studied the table till 15 in class 4 or 3?
Yeah, it's 90.
91. No, 13 sevens are 91. Yes. So it is divisible by 7. 7 into 13. So 91 we write 7 into 13. 91 is also a special number that you have to remember. 13 into 7 is 91. Now all of you please listen. The 7 we will not write exactly below 2. When you write the same primes, we write in a line. Okay, but 13 I will write exactly below 13. So here I leave a blank space. This is to show the common primes. Okay, the arrangement is like this. Then here I write 13. Then here I write which one? 7. On top also a blank space. Is it clear, that arrangement? Is it clear? So when you arrange the LCM and HCF in this method, this is fundamental theorem of arithmetic method, okay? We should write the common primes in a line. Accordingly, we arrange. Is it clear, the arrangement? Now it is very easy to write the HCF. For HCF, we check the common prime. What is the common prime? So 13. Its least power, lowest power is 13 only. 13 raised to 1. Both are 13 raised to 1. So the lowest power is 13 raised to 1. So that is the HCF. So I repeat, for the HCF, take the lowest powers of common primes. Common primes means the prime which is there present in both the numbers. That is which one? 13. So the HCF is 13. Now all of you understood the meaning of that second point in the working rule? Is it clear? For HCF, we take the common prime and the lowest power of that common prime. For example, if first is 13 square and second is 13 cube, then what will be the HCF? 13 square will be the HCF from the common prime. Is it clear? Please write HCF is 13. Here HCF is 13. Now for LCM, we should take each and every prime. Whether it is a common or not, we have to take each and every prime for which one? That LCM. So then multiply that one. 2 into 13 into 7. Multiply. So for the LCM, we have to take each and every prime and multiply. So from the first one, 2 we take. Whether it is common or not, that is not a problem. Suppose this is second is 13. From there we take 113 and next one, what do you take? 17. Suppose the second one is 13 square and 13. Then what will be taking, 13 square. Highest power in even common primes, if it is its highest power should be taken for which one? LCM. Now we understood the meaning of the last sentence. For LCM, multiply the highest powers of every prime. Okay, whether it is common or not, every prime we have to take and the highest power. Now everybody understood how to arrange the numbers and how to take the LCM and HCF. Is it perfect? Now you please multiply this one and tell me. Dash means there is nothing common in this one. There is no 2 in this one. So I put a space here. That's a space for 2. There is no 2 for this one. And here there is 13. So 13 I wrote exactly below the first 13. And then next prime is which one? 7. But there is no 7 in the first one. So I put a blank space there. That means the common primes we should write in a line. That's arrangement. So that way, if you arrange, it is very easy to write the HCF. Okay, LCM, we can multiply every prime. In case in common, if one of the powers is highest, that one to be taken. Okay. So multiply this one. 2 into 13 into 7. What is that? 2 into 13 into 7? 182. 182. 182. So this is the LCM. LCM is 182. So right, HCF is 13 and LCM is 182. Then one more part is there, that is verification. Verify that. The verification means you multiply LCM into HCF. What is that LCM into HCF? 182 into 13. Okay, that will keep in the first line. And second line, you will multiply the numbers, product of the numbers. What are the numbers? 26 and 91, that we multiply in the second line. And you will observe that both will be same number. Okay, that is a verification. So let's do that one. Verification. And before that, from online, everybody understood this finding LCM and HCF?
Yes, sir.
Is it
Yes,
clear?
sir. Yes, sir.
Perfect, right? Okay, fine. So now verification. Yes, this is the verification. First of all, LCM into HCF is 182 into 13 multiply. 182 into 13, please multiply, children, and tell me. 2366. 2366. LCM into HCF is 182 into 13, that is 2366. Then product of the numbers. Yes, what is product of the numbers? Multiply 26 into 91. Yes, please multiply this one. 26 into 91, and how much we get? Is it the same? Yes, all of you please multiply and tell me. 26 into 91. Yes, those who got the answer online, you can send it in the chat box. 26 into 19. Chris got 182. No, multiply 26.
So that was
into
for the
19.
previous answer.
Oh, okay. 26 into 19, everybody multiply. Is it the same number, children? You got 2366, right? 2366. So hence it is verified. Therefore, LCM into HCF is equal to product of the numbers. Therefore, LCM into HCF is equal to product of the numbers. Yes, finished. LCM into HCF is product of the numbers. So let's do one more question of the same type. You understood the method. So let's do one more question. Second question, 510 and 92. 510 and 92. First of all, we have to factorize the prime factorization of 510. Then the prime factorization of which one? 92. Yes. Can you start? 510. Right. $510 is divisible by what number? Divisible by 5. Okay, 5 we can take, or 2 we can take. 5 is fine. 1 5s are 5. Then very, very important. Next number 1 it comes. How do you fill here? 0, 0. Okay, 1 zeros are 0. Then only we take 10. If there is a number in between which we can't divide, we write 1 zeros are 0. Then we take 10. And what do you write? 5 2s are 10. So it is not 12, instead 102, 102. Is it clear? So that is a common error, right? Even small classes also, it was a confusing step. When there is a number in the middle, we will consider 0 there. 5 into 0 is 0. Then we move to the next one. Okay. So it is 102. If you write 12, it is wrong, because 12 into 5 is only 60. It is wrong. Okay, that way logical thinking is also required in that type of division. Now it is divisible by what number? 2. 2, right? So what do you get? 5 2s are 10, then 1. Then again it is divisible by what number? 3. 51 is divisible by 3. What do you get? Correct. 17. 3s are 3, 21 means 17. 17 is a prime number. So we got 5 into 2 into 3 into 17. So 510 we got like this. 5 into 2 into 3 into 17. If you change the order, it is not a problem. We studied in fundamental theorem of arithmetic. You can change the order, but these primes will be there. Next is 92. Yes, can you do the prime factorization of 92? So 92 is divisible by 2. What is IRR when you divisible by 2? How much we get? 4 2s are 8, then 6, 46. Again divisible by 2. 2 2s are 4, 3. 23 is a prime number. So 2 square into 23. 2 square into 23. And how do you arrange this one? 92 is equal to this 2 square we write exactly below. That means here there is a space, right? 5, there is no 5 here. 2 square we write here. Then spaces like this. Then finally we write 23. Is it clear, this arrangement to get the common primes in the same line? Did you arrange like this? Now you understand the meaning of that space in between, because there is no 3 in the second line, there is no 17 in the second line, there is no 5 in the second line. So I kept space, and there is no 23 in the first line. Clear? Yes. Now can you tell me what is HCF? Yes. What is your opinion? Is it 2? It is 2, because from the common primes we take the lowest power. What is the lowest power of this 2 and 2 square? It is 2. So HCF is 2. From online, did you get HCF is equal to 2?
Yes.
All of you found that HCF is 2. HCF is 2. Next, for LCM, what to do for LCM?
So for LCM, do we have to take both the 2s or only one?
From 2 and 2 square, we take the highest power among these two. 5 we take, then 2 square we take. Chris, is it clear?
Yes.
When it is 2 and 2 square, we take the highest among this for its LCM. Then multiply the remaining 3 into 17 into 23. Okay, multiply this. 2 square is 4. 5 into 4 into 3 into 17 into 23. 5 into 4 is 20. 20 into 3 is 60. 60 into 17 into 23. All of you please multiply it carefully. And those who finished online can send me the answer. Chris got it, right? Yes. Oh. Yes. Chris from online, I think some error in the multiplication. Can you do the multiplication again?
Yes.
Chris, who is sitting here, got the answer. Sarah Matthews, correct answer. You got it, Sarah? You're also Sarah, right? Sarah's answer, what is Sarah's answer? After a verification, right? Before that, LCM, how much you got? 23460. How many of you got? That is the correct answer. 23460 is the LCM. Then verification. Finished? Now verification. Verification is LCM into HCF. LCM into HCF is LCM is 2. So LCM 23460 into 2. 460 into 2. How much is got? 46920. All of you found. Then product of the numbers. Yes, please multiply that product of the numbers. Product of the numbers. The numbers are 510 and 92. 510 into 92. Yes, everybody please multiply and check whether you get the same answer. You correct multiplied? Multiply the numbers. 510 into 92. Please multiply it. 510 into 92. 46920. All of you got the same? Next homework question is 336 and 54. Please do not leave the meeting, those who attend online. I'll take the attendance, okay, after that only. 336 and 54 is a similar question, that is a homework question of the same type. And at the same time, if there is doubts, you please ask after taking the attendance. Aaron Jerry is absent today also. Abhirami. Akshida. Akshida. Absent. Alicia. Alicia. Yes, yes. Then Angelina. Ayara. Benita. Benita is Chris Isha Thomas. Joanne Charlie. Josh. Chris Ann.
Present.
Praveliga. Rafika. Raswana. Sarah. Sarah Annie Bobby. Then Sharon. Steve Christ. Okay. Noted. So as I told you, please study this topic. You understood all the concepts, right? You are doing smartly in the class. But that smartness you can express in the examination by practicing it. If you don't practice, you may forget this. So practice it today itself. Okay. So don't be lazy. It is for you. This is very crucial year, class 10. Every day is practice. That only will reflect in the final result. Okay. And